The other two types of hypothesis testing we're going to do on two samples will be on proportions and this idea of matched paired samples. So this first one, we'd like to compare two independent population proportions, and this will use a normal distribution. So again, we're just extending the idea of we studied hypothesis testing on a single population proportion. We'd now like to do this for two distinct groups, understanding what is the difference between those in regards to proportions as opposed to means. But remember, proportions help us, we can form normal distributions with those, and this is our normal distribution. Our mean is 0, and our standard deviation is this guy, where our x's, these are the numbers that have some type of characteristic from each group, and these n's, that's the total number within each of those groups. So we have this as our normal distribution. And then now here, this is where we get to something very different. We did not have anything like this when we looked at a single sample. So we have matched pairs samples. We can compare the differences between two samples drawn from the same pairs of individuals. So some really good examples of this might be if you take a group of individuals and you study them before something takes place. Then you take that same group of individuals after something takes place. You like to compare the difference between those two groups. Now, they're not distinct populations, right? It's the same group of people, but it's before and after some type of event. So maybe that event might be seeing the effect of medication, right? You're going to take a look at this group before medication. You're going to take a look at that same group after medication, and you're going to compare the before and the after. So we're going to see a couple examples of when we can study that, but that's what it means to be a matched pairs, is that you basically have this one person, but there's two copies of them, that they're matching with their before self with their after self, or this first instance and the second instance. So if we want to do hypothesis testing for this matched pairs samples, we make our hypotheses for the population mean for the differences mu sub d. So it's just going to have a single population parameter. And so we're going to be studying the differences, and then we're going to take those differences. There's only really going to be one as opposed to these two means. There's really only this one mean. That's going to be the mean of the differences. And normally how we compute this is going to be after minus before. So when we compute the numbers, just to keep the positive negative, I always do after minus before. So now the test that we're going to use is not going to be a two-sample test. We're going to be using a single population mean test. We're going to be doing a t-test on that for one population, and our degrees of freedom is n minus 1. So we're basically using the same test as though this was one sample, but we're going to have to be calculating differences to be able to use this test. So again, we'll run through some examples to see how do we apply this to the hypothesis testing from start to finish.